Okay, so most of the time, that's what my students saw. I didn't see that at first because I told y'all I see the big picture, I don't see the trees. So my students, a lot of them, we got to do the next three numbers. They noticed that 9 and then went to 3 and then went to 5. And so then this would go to,
Oh, that's so smart.
is that 7?
Yeah, I just counted the zeros.
And some of them said, well, I noticed that the number of zeros was the previous number of 9s, and they went from that. That was interesting. And so the next one, look, my zeros go up by 2. So this would be 5 zeros, because the last it was 3, and then it would be,
Yeah, I didn't. That was so easy.
the mathematical way, everybody, is, look, right, I did right minus left, and I can't remember what I got. This was 110. This was right minus left 1100. This was 11,000. This was 110 million. So I saw that it was a pattern of going up by 110 by a factor of 10.
It was like plus, minus, plus, minus.
Yeah.
That's how much.
Yeah. And so, anyway, that's the way that I saw it. But I love it because even in my master's class, one of the things that they taught us always is to look for patterns. I mean, we think that that's basic, but how many of y'all have tried to work problems and it's like if you work 2 or 3 of them and they all work the same way, that way you figured out that was a pretty good method. So you're looking for patterns, and that's not always true, but it is a very valid learning method, especially in math and things like that. So anyway, I love that we can see that in different ways. Any questions about 2, 6, or 8? We're going to talk about 4 later because it's really challenging. Okay, and number 10, we're going to skip number 10. I'll get there in a minute. So we've got negative 23, negative 18, negative 13, negative 8, negative 3. Now, they wanted you to find the 10th term. So what am I doing every time? Adding 5. So this was a common difference. This means it was arithmetic. So literally you can add 5, and you would go and you get 2, and then you get 7. Your 10th term, your A sub 10, was 22. Okay? If it's arithmetic or geometric, you can always find the formula. So the formula, the A sub 10, A sub n formula would be 5n minus 28. And then you could have plugged in 10 for that. Okay? Watch my video from yesterday. Okay? Number 14. Now, number 14 was also challenging, but I figured that y'all could figure it out. Let me put it up here. This one was neither geometric nor was it arithmetic because it did not have a common difference. It did not have a common ratio, but it did have a pattern. So from here to here, I added 4, and then I added 2, and then I added 1, and then I added 1/2. What can you tell me about the pattern?
That's about 2.
Yeah, you add half of what you added before. So the next we would be 3/2 plus 1/4, then plus 1/8, and then plus 1/16, and then plus 1/32. So your final answer, your 10th term, is 127 over 64.
I did a lot of work though. I was just like,
Well, you can see this is all my little scratch work right there.
yeah.
And I messed up on the first one, and so I was like, I must have punched a number in wrong. Okay? So you can't write a formula for the nth term real well on that, but you can find the pattern. All right, 16. So that was arithmetic. What was the common difference? 9. So you can add 9 each time. The answer for the 10th term is 118. or the formula for the nth term would be 9n plus 28. All right, how did we approach 18, 20, and 22? Those were pretty basic. 1, then 2, then 3, then 4. You've got to fully understand when it's asking for the first 4 terms, that's your n. N equals 1, n equals 2, 3, and 4. So here are your answers for 18, 20, and 22. Now, I'm going to go back and I'm going to tackle 10 first because it's not quite as difficult as number 4. So, guys, the very first thing I'm ever going to do when I see a sequence like this is I'm going to do right minus left. Okay? Now, when I do right minus left, right minus left, right minus left, let's just get our calculators out and let's just try that. So, negative 6 sevenths minus 1. So that gives me negative 13 sevenths.
Minus negative.
Sorry. Thank you. Oops. One seventh. What we're looking for is we're looking for a pattern. So negative 1 minus negative 6 fifths. That's 1/5. Negative 6 fifths minus negative 3 halves. 3/10. Am I doing that right? Did everybody get 3/10 like me? Okay. Negative 3 halves minus negative 2. 1/2. So looking at this, does there look like there's any sort of pattern? All right. So that's not going to work. So now let's divide. And that's why I said sometimes these are long and labor intensive. So negative 6 sevenths divided by negative 1 is 6 sevenths. Negative 1 divided by negative 6 fifths is 5/6. Do negative 6 fifths divided by negative 3 halves. Do it all the way to the end. Negative 3 halves divided by negative 2. Do you see the pattern? What's happening to the numerator? So, and then the denominator going up. So, now a lot of times with fractions, guys, particularly in sequences, listen to me, with fractions, you actually want to look at the numerators separate from the denominators. If you look at 3/4 and 4 halves and 5/6 and 6 sevenths, if you look at them as a whole or looking at them as a decimal, they won't make any sense to you. But if you look at what's happening with the numerator and look at what's happening with the denominator, what would I multiply this one by next? 7/8. And I'm going to get something. And then I'm going to multiply that one by 8/9, right? And I'm going to get something. And then I'm going to multiply by 9/10. And I'm going to get something and multiply by 10/11 till finally you get your 10th term, which happens to be negative 1/2. I don't know where that ends up. I think you have to do one more. No, 11 times 11 twelfths. give you your final. You have to look for the pattern, and the easiest way to do that is start right minus left, then start right divided by left. Now, we're going to go to number 4, which does not do any of the above, okay? So, if you did right minus left, it doesn't work. If you did right divided by left, it doesn't work. So, I have a couple of takeaways. I told y'all the other day that I'm going to try to do takeaways and most important points every day, or at least with each lesson. Okay. That's a comma, not a 1. Let's just do dot, dot, dot. No apparent at all. Nothing with the numerator, nothing with the denominator. Okay? So, the first most important point, write these down. Write your n equals 1, 2, 3, 4, dot, dot, dot. Okay? Okay? If fractions are involved, unsimplify. That's a must. Any fractions involved at all, unsimplify. So let me start. 1/2, the first one I'm not going to unsimplify. The first one is usually the one it needs to be. What is the next way that I could write 1/2 in an unsimplified, but like next to the simplest form? 2/4. Okay, you're going to see it here in just a minute. 3/8 is in its simplest form. How else could I rewrite 1/4? You're starting to see something, I hope. 4/16. And then when you unsimplify the fraction, now keep in mind again, I told you n equals somewhere, put n equals 1, 2, 3, 4 where you can see it. All right, so we have to write this. Let's look at this box right here, because I know I've got a lot up here and it's hard to follow. You've got these in the unsimplified form. Yes, the top numbers are going up by 1, but they also match the what? The n. So what can I say about the formula for this one? The a sub n is n over something. Now, we can't do n plus 2 each time because it's not multiplying by 2 each time. Guys, we can't even put 2 in. Let me explain why. Listen, look up here. If I put 2 in, oh yeah, 2 times 2, oh yeah, that's going up by 4, but this isn't the n. That's the denominator. The n is 1, so yes, it works for that one. 2 times 1 is 2. It works for this one. The n's 2. 2 times 2 is 4. Does it work for 3? Does it work for 4 or 5? So, if it doesn't work by multiplying, then another trick that they always do, hey darling, I'm sorry, I just said it. No, you're fine. Just pick another one, as long as they're, I've gone ahead, there were several who had put 4 on there, so just pick another one that's got, I should have them crossed out in blue if they're unavailable. Okay, so we know that this one won't work. But another trick that they love to do is use a base of 2 or a base of 3 raised to the nth power. So 2 to the first power is 2. 2 raised to the second power is 4. 2 raised to the third power is 8, and so on and so forth. So that's why I said that one is extremely difficult. But 2 most important points here. You want to have your n showing. If you don't have your n written down above the term, you're not necessarily going to make the connection to what are the n's. You'll say, oh, start with 1 and add 1 each time. No. Those can be your n's. Now, how would I manipulate my n to get the denominator? Okay, questions on that one? Okay, so again, you won't have anything that tough on your quiz tomorrow, but that's not to say that they won't be difficult come May. We've got more work to do on these. Okay, so right now, just do 24, 26, and 28 for me. Now, those are straightforward. Do 24, 26, and 28. It won't take you but just a minute. You're just finding the 10th term. All right, 24, you got a great big number, 262,144. So all you do is put n in, 10 in for n. Okay. 26, you got 100. And 28, 361. Are those okay? All right, now, let me go back and explain something just real quick. This is what is known as an explicit formula. Okay, it's telling you what you do. It uses only n's in the formula. The other ones would be a sub n equals 2n minus 28. That's an explicit. Okay, we're going to talk about that in a minute. We've got one to do at the bottom. A recursive, and again, we're going to talk about these more in detail in a minute. A recursive, now when I see the word recursive, I think recurring for some reason. And so it's ones where we use the previous term. Look at 30. 30 is a recursive formula. They want you to find the first 4 terms in this sequence starting with 1, negative 1, I'm sorry. Think okay? Okay. All right, so now, I want everybody to look up here because this is not hard, but if you're not paying attention, you're going to be like, what? What is she talking about? Okay. So, your a sub 1 is negative 1, right? That's your first term. They wanted you to find the first 4 terms, right? I don't have n here. I have n minus 1. So then I want to find the second term, correct? What is my n here? 2. So I want to, n is 2. Everybody look up here, watch me. So if I put a 2 here and do 2 minus 1, what do I get? So that now says I'm going to use a sub 1 times 2. Let me say that again. My n is 2. I'm fixing to find the second term in the sequence. So if my n is 2, I put a 2 here. That becomes a sub 1 times 2. Everybody follow me. What is your a sub 1? Negative 1 times 2. So my second term in the sequence is?
Bus riders, if you will listen, please. Bus number 18, bus number 33, and bus number 31 are all going to be late buses today. So that's 18, 33, and 31 are all late buses today. Thank you.
Okay. We're going to take it step by step. So now I want the third term. So what's my n? 3. So I put 3 minus 1, which gives me a sub 2 times 2. What is my a sub 2? Negative 2 times 2. What's my third term? Negative 4. Now I'm going to find the fourth term. N is 4. 4 minus 1 is a sub 3 times 2. What's my a sub 3 term? Times 2. My fourth term is negative 8. Who can tell me the translated in your own words version of what I just did?
Isn't it would be negative 3? Times 2? Because it's a sub 3.
But what was my a sub 3? That's just telling me which term to look at. What it's equal to. I'm just substituting in there. So, in your own words, what does a recursive formula basically tell you to do? Use the one before it. And you do. You can't just put in the 10th term. Okay? If they want you to find the 10th term, more than likely you're going to have to work them all out by using the one before. Does that make sense? In every one of these, you have to tell me the first term. Otherwise, I don't know where to begin. They have to give you, in the recursive, they have to give you the first term, whether it be negative 1 or negative 10 or 300 or 1052. You take so whatever this tells you to do, the n minus 1, all you do is take that, the previous term, and do what it says to do to it. So let's see if y'all can try 32 and 34. Now, you don't have to write these out this much, as long as you understand recursive. We're just taking the previous number and doing the same thing to it each time. But you have to start where they tell you to start. Okay, so let's look up here. Now, this one is a little bit different than the other ones. We're going to start with a sub 1, and they told us that's 6. So, to get a sub 2, we don't do anything when they give us the first term. That is our first term. The a sub 2 means that your n is what? 2. So you're going to take your previous term, because 2 minus 1 is a sub 1. A sub 1 is 6. So 6, you're going to add your n of 2. What's your second term? 8. So the third term, your n is 3. You're going to take the previous term, that's what recursive means, add your n, my previous term is 8, add 3, and I get 11. A sub 4, my n is 4, take the previous term, 11, add the n, it's 15. Now, where are your questions with 32? That's starting to make a little bit more sense. Okay. You really like these because you're able to see the pattern a little bit easier, but the way the formula is written is always a little challenging to understand at first. 34, a sub n equals 2 plus a sub n minus 1 over 2, where your first term is 10. So my a sub 1 is 10. I never have to do anything with that. So I take my previous term. So this is 2 plus my previous term. So 2 plus 10 is 12 divided by 2. That's 6. A sub 3, 2 plus my previous term. 3 minus 1 is 2. The a sub 2 is 6. 2 plus 6 is 8. Divided by 2 is 4. The fourth term, 2 plus 4 is 6. Divided by 2 is 3. That would be a very hard formula to come up with if you had to look at 10, 6, 4, and 3 as your pattern. Okay, so now let's look at 35. They want us to find the 10th term, and they're going to give us a recursive, which means we have to do all 10 of them. Okay, so a sub 1 is negative 1. That's all, my n is 1. All right, so my a sub 1 is negative 1. My a sub 2, what's my n? 2 times my previous term. So that becomes negative 2. My a sub 3, what is my n? 3 times my previous term. 2. And negative 6. A sub 4, negative 24. About to get out of what I can do in my head. So keep going until you get to the a sub 10. Okay, I'll just stop for a minute. phones put away, and you will see that your last is negative 360, negative 36,200. No, negative 3,628,800. Okay, did we get that? We didn't raise our hands, please, so I know. Okay, so go ahead and do 38 and 40. That was 36, not 35, sorry. One bad thing is if you get off on one number, it's going to affect your outcome, so you need to be extra careful or go back and check. On 38, what were you doing to the previous number each time? Multiplying by 3. So your 10th term is negative 59,049. And on 40, you're multiplying the previous term by negative 2, and it's 1536, your ace of 10. Okay, so let's talk about, again, the difference between an explicit and a recursive, and then I kind of have to explain recursive in the Cambridge terminology, which is inductive, which changes things just one minute hair. Okay, so explicit just uses the N. So if you had 5, 9, 13, 17, okay, and I wanted the explicit formula. This has a common difference of what? 4, a D of 4. So you would find however you want to from my notes yesterday. We know that that's 4N plus 1. That is the explicit formula. Okay? If we had that is a geometric or arithmetic. Geometric with a common ratio of 3. Hold on. Go back and look at your formula. Pull out your formula sheet if you want the geometric. It's on your formula sheet. It's a 3 to the n minus 1. A times your r raised to the n minus 1. Make sure you have your formula sheet. That would be an explicit. Okay? Now, what a recursive is a recursive is the one that uses the previous term. So let's say we've got 2, 4, 6, 8, 10. Now, the explicit form of this would be 2n, right? That would be the explicit form. But I don't want the explicit form, I want the recursive form. So we do a sub n equals, what am I doing to each one of these? Adding 2, so it's a sub n minus 1 plus 2, and you always tell me the first term in a recursive, because I can't plug in is 1. Now, let's go ahead and we're not going to do the explicit on 42 just yet because that one's tough. Let's look at 44. See if you can write me the recursive formula. For 44, the recursive. Let's start off with a sub n. What am I doing to every term? Adding 200. So how would I note that? You have to tell me where to begin. Now, the book in Cambridge uses something that's similar to recursive called inductive. So get out your P1 books and turn to page 1, I think it's page 115. Yeah, page 115. So, I always give you the long of it, and then I try to give you the short of it, because I want you to understand where things are coming from. So, let's start back with this very easy one. Now, if I were to write the recursive formula for this, it would be a sub n equals a sub n minus 1 plus 2, where a sub 1 is 2. So, let's make sure we understand. If I give you a number here, that stands for my n, right? So if I want a sub 2, then my 2 is my n. 2 minus 1 is 1, so that's my a sub 1 plus 2. That's how I come up with that. The way they write it as an inductive is they look at it not from the previous term, but from the next term. So they're not saying from the previous, so you start with a sub n plus 1. What is the next term going to be? Well, it's this term plus 2. Now, let me show you, and I'm going to show you the long of it, and then I'm going to show you the short of it. If I ask, and a sub 1 is still 2. So if I ask for a sub 2, okay, now, a sub 2, this was the only thing that's got one number is this one, a sub 1. That becomes your starting point, right? That 1 is your n. So what does 1 plus 1 make? 2. So then you take your a sub 1, which is 2, and add 2, which becomes 4. So all they're doing is they're just flip-flopping it. Instead of writing it like this, where we take the previous term, they write it where it's like, okay, the next term is the one before plus 2. So here's the short of it. I take this 1, I move it to the other side of the equals by doing what? Adding. That's it. That's the short of it. But I want y'all to see why. This one is saying, okay, 1, well, the next one would be a sub 2. 2 minus 1 is 1. That's the one you use. This one is saying 1. 1 plus 1 is going to give you 2. That's your a sub 1. So we're going to do a couple of these, and we're going to do them both ways. Because I need to go and double check. I want to make sure that they would accept our recursive formula. But I want you to really be able to do both, just in case. And it's not that hard. So let's look on page 115. We're going to do 2C. I've already done A with you. And we're going to do it, label it R and label it I. We're going to do both recursive and inductive. So the recursive formula, what am I doing to this every time? Adding 4. So my recursive always starts with a sub n, and then I would write a sub n minus 1, the previous one, and then I do what? Plus 4. I'm taking your next number, your a sub 2, is your a sub 1 plus 4. That's it. Now we're going to write it as an inductive. A sub, I have to write a sub 1 equals 2. Make sure you put that out there. So how do I write it as an inductive? A sub n plus 1 equals a sub n plus 4. That's it. So if it has to be where they want the inductive, then let's just write it as the recursive the way we see it, and then we can just flip-flop it. Who's got questions on that? Okay, go ahead and do E. Now E, see what you can figure out about E. will tell you there was no common difference on this. There's nothing that you can add to get the next number in the sequence. But what could I do to get the next number in the sequence? Multiply by what? Or did anybody else do something other than multiply?
Like square root, but not square root. The power that I added.
Okay, I'll have to, let me look at, because some of it, let me see, because it may be another pattern that works. The other one you could have done is divide by 3. Multiply by 1/3 or divide by 3. Okay, so let's do the recursive first. So our a sub n equals a sub n minus 1 times 1/3, where your a sub 1 is 1/3. You could have put the 1/3 on the front. That's perfectly okay.
Just put it right there in front of. Oh, I thought you meant the.
So it doesn't matter as long as you're a multiplication, it's commutative. The inductive would have been what? Either before or after, it doesn't matter. Always be sure and tell me that a sub 1 equals 1/3. All right, any questions on writing as a recursive or inductive? You may not remember the inductive. It's kind of like when I'm made to use my left hand. Like, my default is my right hand. My default is my recursive, but if I write the recursive, it's really easy to also write the inductive. Okay, so I'm going to work the next 3 for you before the end of class because they're a little bit difficult and I want to show you how they work. So write them down for me, please. So no numbers here. What did I tell you what I always start? The first thing I always do anytime I have a sequence. What? Well, I can't simplify there, but yeah, that could be one thing. I do what? Yep, that's one of them. Just in case I need it. And that's not b cubed, so sometimes it's not the way I have it written. I don't want to look like I'm squaring and cubing these things. What am I going to do now? Yeah, but how can I come up with that? You may have seen that easily, but for some people who don't see that, what can I do?
If they all have to be, could you take 3 away?
No, you have to look to see. So one thing I can always do, didn't I tell you to find a common difference? And this is the first thing I do when I'm checking to see a sequence, is I always do right minus left after I number it. Always right minus left. So my furthest right is b plus c minus the one to the left of it. So that gives me an add c. I take b. Now be careful. What's my mistake here? I did right minus left.
You gotta
Do what?
put parentheses.
It's a polynomial. So that would be b minus b plus c at a common difference of c. Let's look at this one. B minus c minus so I have a common difference of c here. Right divided by left. I don't have to have numbers to do this. Works the same way. Trust the process. Works the same way. So my common difference is C. So let me write a recursive, then I'm going to write an inductive. So my recursive would be A sub n equals A sub n minus 1 plus C, where my A sub 1 is B minus 2C. Yes, ma'am.
How would you go back in and put the b minus 2c where the n is minus 1? You know, like when you're going
No.
back
Okay, n is 1. I'm going to start with B minus 2C. So my n is just 1. It's not this. So when I want to find, I've got my first term, right? A sub 1. So now I want to find A sub 2. So 2 is now my n. So A sub 2 minus 1 gives me A sub 1, which was plus C. So now my second term is that. Okay, too many letters, right? Too many. Okay, so this is my recursive, my inductive is that, keeping the A sub 1 the same. All right, I'm going to quickly try to get done with I and K. Write I down for me. Now, guys, what's happening with the numerator? It's staying the same. P, P, P. What's happening with the denominator? Not being divided by Q. Well, on the bottom, the powers are actually going down. So let's try your theory. Divide it by Q. I'll put it in red. If I divided this by Q, it'd be the same thing as multiplying by 1 over Q, right? If I multiplied by 1 over Q, what would I have here? P over Q to the 4th. That's not what I've got. How can I get the Q's to go down? Or no, not the same. That's right. It's not the same as dividing by Q and dividing by 1 over Q are two different things. Dividing by Q is multiplying by 1 over Q. Dividing by 1 over Q is multiplying by Q. I know, y'all just went looking at me. So if I divided by, let's just make this easy, what could I multiply by? Just a Q, because a Q here cancels with one of those, leaving me Q squared. If I multiply this one by Q, that cancels, leaving me Q. No, it's late in the day. Y'all following me? Or questions? Yes, sometimes you're going to divide and sometimes you're going to multiply. So, what am I multiplying each one of these by? Q. So, my recursive would be A sub n equals Q times A sub n minus 1, where my A sub 1 is P over Q to the 3rd. My inductive 8n plus 1 equals q a to the n. Same.
So can you divide by 1 over q? That also be acceptable.
Yes, except that will look really awkward,
Yeah, it's ugly.
which really is not technically mathematically
I just did like
correct.
divide.
Yeah, it's the same thing. So yeah, because when you divide by 1 over q, you're multiplying by q. Yeah, so you could write it like that. Yep, that would be perfectly acceptable. All right, let's look at the last one. K. This one's a little bit easier. All right, obviously I'm doing what with a number?
Square the power.
But I don't have a 5 here. Do what? Multiply by 5, but not 5x. Because if I multiplied x to the third by 5x, I'm going to get 5x to the fourth. That is not what I have as my second term.
5 over x.
5 over x. So if I multiplied x to the third, oops, didn't mean to draw that line, times 5 over x, then that would give me 5x cubed over x. One of those would cancel with that, giving me the second term. Let's try it again by 5 over x. So 5 times 5 is 25. X squared divided by x is x. That is my pattern. So the recursive is a sub n equals a sub n minus 1 times 5 over x, where a sub 1 is x cubed. Or your inductive, a sub n plus 1 equals a sub n times 5 over x. The 5 over x can go front or behind with the same a sub 1. Now, you'll not have any, your quiz tomorrow is very, very, if you'll notice, I gave you all the what on your worksheet today? I gave you all the, look at the numbers. Evens. So guess what tomorrow's quiz is going to be? The odds. So it's not going to be, the majority of it is not going to be inductive or explicit or recursive, okay? But this is something that we've got to get good at.